Welcome to Ask and Learn.
Okay, so for this problem, you have a sheet. Ooh, that is crooked. A sheet with some charge that's negative, and you have a electron that's shot at it, and then you want it to stop after it's reached here due to the repulsion. And so the goal is to get how far, if you wanted to stop right at the sheet, how far should you launch it? How far from the sheet should you launch it? Let's go ahead and write out our givens. So the kinetic energy initially is this 1.6 times 10 to the minus 17 joules. And then what else are we given? And then the surface charge density is minus 2 times 10 to the minus 6 coulombs per meter squared. This is a classic energy conservation problem. And basically what you want to do is you want to say, okay, the initial energy has to be equal to the final energy. So initially there's potential energy and kinetic energy. And then ideally, finally, we want it to stop. So there's no kinetic energy, but there is some potential energy. And so you can get that KE initial equals the change in U, where the change in U is U final minus U initial. So let's start plugging things in terms of things we know and things we want to find. So I guess I'll write down here that we want to find D equals question mark, where D is this distance. So in terms of things we have, delta U is going to be Q times the change in potential and electric potential. And then for an infinite sheet with a constant field, that's just Q E D. And then, yeah, we already have the initial kinetic energy. And then E is the electric field due to this sheet. And so then we can use the formula for that, which is sigma over 2 epsilon naught times D. And then so algebraically manipulating that. Let's see how much room I have I can write all the way to the edge. Awesome. Okay, algebraically manipulating that, I get that D is equal to, oh no, I didn't erase it. Okay, well, whatever. Forget this whole little scribble section. Okay, I get that D is equal to the kinetic energy initial divided by Q sigma over 2 epsilon naught. When I plugged that into a calculator, I got 8.9 times 10 to the minus 4 meters.